Hello and welcome. In this video, I'm going to show you the basic configuration of BGP on OcNOS devices. The topology consists of multiple autonomous systems connected to each other. What I'm trying to do in the next videos, I'm going to show you different topologies, different technologies, and different BGP settings on each one of these autonomous systems. Right now, I'm going to show you how you can configure simple BGP adjacency on 4 iBGP neighbors on AS200. Let's just take a look at the topology in a little more detail. So on Autonomous System 200, you can see that I have some devices here. Most of them are connected to each other, but there is no physical connection between router 8 and router 9. Autonomous System 200 has been configured with an IGP. I have configured OSPF, and some of the loopback interfaces have 2 addresses, but I have not advertised both of them into OSPF. Let's check the configuration of router 8, for example. If I go to router 8 here and log in using OcNOS, and I'm going to go to enable mode, I'm going to say show run router OSPF. This is a simple configuration of OSPF. As you can see, there is just a router ID set. One of the IP addresses set under the loopback interface is advertised, plus 2 interfaces internal to the autonomous system, which means that the interface which is connected to the other autonomous system, which is Ethernet 2, is not advertised into OSPF. Now on router 8, if I just say show IP OSPF neighbors, you can see that I am neighbor with router 10 and 11, and the same commands of course could be run on other routers so that you can see everything. So let me just change something here. I'm going to say terminal width. I'm going to increase it to 256 so that I do not really see everything goes to the next line. And I'm going to run this command one more time. Let me just do this on all of the devices, and for that I'm going to go to here and say OcNOS, the same thing here, OcNOS, and also on here I'm going to log in so that I can just enable this command on all of them and hit enter. Okay, so let's go back to router 8 and see everything. The last thing that I'm going to do before configuring BGP is show IP route. Now you can see that in this area, which is configured with area 0, I have access to almost every prefix that I want to have. And also show running configuration of interface loopback tells me that there are 2 IP addresses set, but like I said, this one is not advertised into OSPF. Okay, let's go with the simple configuration of BGP. There are some steps that I want to take, but I'm going to mention some stuff here. The first thing, I'm using loopback interface because as you can see, I have multiple paths to get to different parts of the network. And this means that using loopback is going to enable me to have a connection in a way that in case one of these links go down, the other link is going to take over and my TCP connection is not going to break out. The other thing is I'm going to use the update source specifically with the IP address, not the loopback interface. The reason is loopback interface has multiple addresses on them, and I'm going to receive an error in case I have multiple addresses on them, and I'm just specifying the interface loopback as the update source. Next thing that you should know is I'm going to configure iBGP. This means that the TTL is going to be set to the max, which is 255. That means that I can just be adjacent with neighbors up to 254 hops away from me. That's okay, but most of the time you do not have so many hops between you and your destination. So what you do is you just configure something which is called TTL security. TTL security is exactly the opposite of multi-hop. And this means that if I set TTL security to 250, I mean that anything that is received by me, if any packet that I have received has a TTL of 250 and more, that's okay. If it is less than 250, this means that it has received by me from farther in my network, which I don't really want to have adjacencies with them. So in this case, what I'm trying to do is to just drop those kind of connections. Now, I'm not going to configure TTL security here. I just wanted to mention that there is such a configuration, which you should be very careful about that. Something else that you should note is, although router 8 and router 9 do not have any physical connection, but they can be accessible through other routers. So I can create an IBGP adjacency with these two. That means that I can create a full mesh of adjacencies here, which is good. Of course, most of the time this is going to help me not to have any black hole in my network. But I'm not going to do that. What I'm trying to do is to create adjacencies between router 8 and 10 and 8 and 11. Also between router 9 and 11 and 9 and 10. I'm not going to create any adjacencies between 10 and 11. So that's going to be the plan for now. The configuration is super simple. So I'm going to go to router 8, go to configure mode, say router BGP 200. And because my loopback interface has multiple IP addresses, again, I'm going to make sure that one of them is specifically here set as BGP router ID. So I'm going to say BGP router ID is going to be 8888. Now, the neighbor adjacencies. So I'm going to say the first neighbor is going to be 10, 10, 10, 10, which is in remote AS 200, which means that this is going to be an IBGP neighbor. The next thing, I'm going to say update source, but like I said, instead of the interface, I'm going to go with the actual address. 8888 is going to be my update source. Let's configure the other neighbor as well. So I'm going to say neighbor 11, 11, 11, 11 is in remote AS 200. And this neighbor, of course, is using an update source of 8888. So hit enter. Now, on some platforms, you know that the only address family which is enabled is address family IPv4. In OcNOS, IPv4 is not enabled by default. So what I mean is you need to create this address family first. So what I'm going to do is to say address family IPv4 unicast, which is going to enable this address family. Then I'm going to say neighbor 10, 10, 10, 10. I need to activate that neighbor here. And neighbor 11, 11, 11, 11 is going to be activated as well. So I'm going to commit the configuration, save the configuration, and show you the running configuration of router BGP. This is my configuration so far. Let's do the same thing on router 9, and for the sake of simplicity, I'm just going to copy that because this is super simple. I'm going to open Notepad. I'm going to paste it here. The adjacencies are going to be the same, but the update source, of course, is going to be 9999. Here, the same thing, 9999. So I'm going to just copy and paste this configuration on router 9. Going to here, go to enable mode, go to configuration mode, and then I'm going to paste the whole configuration in here and commit, and of course save the configuration. Okay, let's go to router 10. Now router 10 is going to connect to router 9 and 8 based on the topology, as you can see. Router 10 is not going to have any adjacencies with router 11. So I'm going to just change this configuration a little bit and then apply it. So that's going to be router 8888, which is in remote AS 200, and it is going to have an update source of 10, 10, 10, 10, and it is going to be activated here. The other one is going to be 9999, which is going to have an update source of 10, 10, 10, 10, and it should be activated down here. And router ID, of course, is going to be 10, 10, 10, 10. So let's check the configuration to make sure that there is no error in that. And then I'm going to copy the whole configuration, go to router 10, go to enable mode, configuration mode, and paste it here and commit, and also save it. Okay, this part is done. The only thing left is 11. So let me just go back to router 8. I guess I did some mistake here, which I need to be careful about that. So I'm going to say router BGP 200, and BGP router ID should be 9999. And then I'm going to commit the configuration and save the configuration as well. So let's modify this for router 11. So this should be 11, 11, 11, 11. And then I'm going to copy this and replace these with 11, 11, 11, 11. And you can see that the rest of the configuration is quite the same. I'm going to paste it on router 11. So I go to configuration mode, paste it, and then I'm going to commit the configuration, save the configuration. Great. Let's do some verifications. On router 11, I should have adjacencies with 8 and 9. If I say show IP BGP summary, let's say just like this, you can see that I have two adjacencies. Both of them are up. Both of them are in AS200. And I have not sent or received any prefix yet. I'm going to check that. The same thing should be done on other routers. So I'm going to just copy this and paste it here for all routers. So router 10 has two adjacencies, 8 and 9. Router 9 is adjacent with 10 and 11, and the same thing on router 8. Okay, let's do something. What I'm going to do in this case is I'm going to advertise some routes into BGP table. The routes that I'm advertising have not been advertised into OSPF. So let's do this. On router 8, like I said, if I show you the running configuration of interface loopback, I have two interfaces, and this one has not been advertised into OSPF because I want to advertise it into BGP. I should go under BGP address family. Then I'm going to say network is going to be this, and hit enter. Then commit, and then I'm going to save the configuration just to make sure. If I go to router 10, I guess I have done the same thing here. So if I say interface loopback, I have this. I need to advertise it into BGP. So what I'm going to say is router BGP 200, address family IPv4 unicast. Then I'm going to have this network here, network, and paste it. Then I'm going to commit the configuration, and also I'm going to just save it so that next time that this router comes up, it is not going to lose any configuration. Now if I say to show IP BGP and hit enter, you can see that I have these two in my BGP table. The first one is 8889. I have received it from 8888. And the metric is 0. You can see the weight is 0, and this is interesting because weight is Cisco specific, but OcNOS supports that. And sometimes when you want to do some traffic engineering, weight is going to help you a lot. Now weight is 0 because weight is something local. This is not my prefix. I have received this prefix, so weight is going to be 0. This next one, of course, is my prefix, so I have set the weight to the default value, which is 32,768. And this 0000 as the next hop, most of the time when you see 0000, it means me, unless it is going to intend reaching out to default route. But this one, of course, means me. Okay, so the configuration is done. We have done some verification, and everything seems to be good, running, and okay. So let's just check the topologies for a few notes here. I have router 8 here, which has advertised some of the interfaces into BGP table. Now router 10 and 11 have received these prefixes, but does router 9 know anything about router 8's prefix or not? The rule says if I receive a route from my eBGP neighbor, then I'm going to advertise it to any other eBGP neighbor or IBGP neighbor. But if I receive a route from my IBGP neighbor, then I'm not going to advertise it to any IBGP neighbor. Only eBGP neighbors are going to receive this. Now, with this, router 8 has advertised something into R10 and 11. Are those going to advertise it into R9 or not? So let's go to router 9 and check this. If I go to router 9 and say show IP BGP, you can see that I don't know anything about the route residing on router 8 based on the rules. And there are some different types of fixes for that. One of them configuring as route reflector, which I'm going to do in another video. But for now, I guess everything seems to be cool and okay. My IBGP adjacencies are up and running, and the configuration was super simple. I'm going to continue in another video. I hope this has been informative for you, and see you in next videos.